Hi, I'm Dave Robinson, and welcome to another weekly screencast where I use R to analyze a dataset I've never seen before. As usual, this dataset comes from the Tidy Tuesday project. It's a great project from the R for Data Science online learning community that every week releases a new dataset. So let's see what we have this week, right? I haven't done last week yet with Nobel Prize winners or global plastic waste. Both sound really interesting. I'm going to do Nobel Prize winners. All right. It sounds really exciting. So, here I'm analyzing a data set about Nobel Prizes. Let's see. I think it comes in Dataverse. Do Nobel laureates create prize-winning networks? Oh, that's interesting. So there's network analysis, but it's not included in this data set, but maybe I'll pull that in. Maybe. We'll decide. There's a lot we could do here. Okay, and Nobel winners, all their publications. Well, a lot of data to grab. So what I'm going to do is go into our studio, create an RMD, library tidyverse, and we get started on our Nobel Prize winner data, Nobel Prize winners. So we have about 1,000 Nobel Prize winners in this data set. It should be spread across 6 categories. Yes, economics was introduced the most recently. No, I think economics was introduced later. I don't know that much about this, but also prizes can be shared among people, which is why you have some getting more. Maybe medicine had a lot of collaborators. Let's, just to get a feel for this, take a look at what's laureate type. There's lots of cool data here. Some are individuals, some are organizations. Okay, so if I counted category and prize year, and then I did a graph, probably going to change it to decade, but prize year, N fill equals category, geom call, I'm going to get stacked bar plot, just so I can understand, let's make it by decade. I do this a lot, is I do 10 times this. This is truncated division by 10. Here we go. So this is the number of prize winners by decade. 1, 2, 3, 4, 5. There it is. It's that economics was introduced in, it looks like, the 1960s. So so there were no economic prize winners early on, but we also noticed that physics used to be, well, about 10, like a little more than 1 per year, and then eventually turning into more like into more and more prize winners per year. So what's interesting is I can actually say, instead of counting, I can do a group by, and I summarize I can say then the winners are N, but I can also say the winners per year are, now this is actually a little, yes, what I can say is winners divided by N distinct year. Not all decades are going to have 10 years. The current one isn't, because I don't think the 2019 have been announced yet. And some of them maybe were, like economics started midway through a decade. So, prize year. So N distinct is a handy little graph for this. Oops, I'm missing something. I see what I'm missing. I need winners per year. Here it is. So, and I don't want this to be stacked anymore, which means instead of being, because you can't add winners per year, instead I'm going to do a geom, meaningfully, I'm going to do a geom line. And what we see here, expand limits y equals 0. Can't have few. So here's what we see. Literature almost always has 1 winner per year. But medicine, number of winners per year has been going up. Physics, has been going up. And economics was introduced in the 60s. And that's consistently about 2 per year. All right, so that's some things we just learned about this data. What else do we know? There's so prize share is also about, if I counted prize share, we get a feel for, like, sometimes they divide in half or thirds. I think sometimes it can be like a half and two separate quarters, but maybe, but probably not going to be all that common. Okay, we have genders, we have birth, city, we have when they died. All right, so what are some of the questions we could ask from this? Well, one I would ask, all right, let's see. One I really like asking is who's won multiple prizes? I'm pretty sure Linus Pauling, Marie Curie have each won 2 prizes, I think. All right, looks like the Red Cross has won 3. And in what categories, I wonder? If I want to know what categories, I could probably do add count full name, which adds a column count, arrange descending, and like that end column is counting it. And then I can do select prize year, category, and full name. Paul Ehrlich, yes. One twice in the same year. That doesn't make any sense. Well, okay, so some, like Red Cross, win 3 times for peace. Some win 3 times in the same year. Let's look at that. That's a little puzzling. I'm curious about that. Filter, category equals medicine, and full name equals, yeah, Marie Curie won for physics and for chemistry, but full name equals, these look like 3/3 that are all the same for the same prize, which is for the discovery of how. Why? Well, that's really strange. It looks like the same person shared all 3/3. Maybe a data error. I think solid bet there's probably a data error. So in any case, we certainly what we can do to fix this is say distinct full name and prize year, and while we're at it, category. Now that I've done a distinct, I actually don't need a select anymore. So I can do my, where's my add count? Ah, yes. Here it is. And by full name, just so the ties are together. Sanger has won twice for chemistry. Bardeen twice for physics. Pauling for chemistry and peace. Curie, I think, for physics and chemistry. If I'm remembering my trivia questions correctly. And, yep, UNCHR for peace twice in 2 different years. So that's actually interesting. Instead of adding a count, I might want to let's see. I might want to group by and then say mutate prizes equals n distinct prizes equals n distinctive category. I'm missing something. Oh, here it is. All right, and then we can see that, there it is, that Pauling and Curie are the only 2 winners to win in 2 separate categories. It's not so much data analysis as it is like discovering trivia, because I wouldn't put that on a graph or anything, but it's certainly interesting. Okay. All right, what's the gender breakdown been like? That's another column that I saw that I'm immediately interested in. So I take my winners. I always really need to do a I now have learned. In fact, here's what I'm going to do. I'm going to clean this step. What I'm going to do is say distinct distinct full name, prize year, and category. But I'm going to say keep all equals true. If you haven't seen this before, what it does is ensure that I now have a fewer rows because I'm not duplicating the same person multiple times in the same year, but I keep all the other columns. I actually keep having only the first row in that table. So if I take my my winners, and now I don't have to worry about that anymore, and I group by, let's actually add decade here. Ooh, I didn't need sort equals true. Add decade in this in here because I'm going to use it more and more often. And now I can just group by decade right here. group by decade. I could group by, or I could count. Count decade, and let's start with decade and gender. I guess we have many organizations in here. They don't have gender. I'm going to note, let's see. I want to quickly check, does anyone not have a gender that's not an organization? This is let's see. So if I said not isn't a gender, and laureate type, I actually meant isn't a gender, laureate type equals organization. I meant not equal to organization. Quick data clean. Okay, so it doesn't pop up. What I'm going to do is count gender, but I'm actually going to, to coalesce. This is a function that says if gender is an A, use the laureate type, which will fill in organization, or if that matter, if it was individual, it would have counted it. And now I can actually say plot decade and fill equals gender. Here we go. Overwhelmingly male is the first thing. It's been, though that has been changing. Not as rapidly as it could be. It's actually hard to tell on a percentage basis if it's changing. Organizations fairly even across all of this. And let's see, what if instead I group by decade? I was thinking, what if I do it on a percentage basis? Percent equals n over sum n. There's a trick that I said, is I say within each decade. Then I create, this is called, I believe, a spinogram. And this shows like gender breakdown, men, women, organization. And generally, in fact, it hasn't really been getting more diverse. In fact, there's not a single Nobel Prize went to a woman in the 1950s. I'm going to facet this. That's remarkable. Remarkably unfortunate. I'm going to facet this by category, which I need to throw into the count. Group by decade, and I'll throw in a category there. That way the percentages are within each category. All right. One thing this shows, I actually was expecting literature to be more even than others, and it is in the last 3 decades. We're seeing there about 70% male. Economics, wow. How many women have ever won the Nobel Prize in economics? Filter category equals economics. Only one woman has ever won the prize in economics, and it looks like only 2 in physics. Maybe more. I think 2. Let's see. In economics, I definitely expect it to be shifted, but honestly, I'd expected it to be improving a bit faster over time. Yeah, so it looks like only 2 women have won. So this will be Marie Curie here. I don't know who this is. And yeah, let's see. So medicine, at least there's someone each decade. And peace has more recently started shifting towards 50-50. Yeah, that's interesting and certainly unfortunate. All right, so this is breakdowns, and we see that the Peace Prize, that only the Peace Prize is the only one that is ever given to organizations instead of individuals. Okay, so this is a solid graph. I'm first gonna be curious. Is this graph better if I look at it not on a percentage basis? Yeah, I actually like it a little more in here. Because in this graph, because one thing is that percentage, it's hard to see. Oh yes, it's one woman in each year. Here I can really see that. Okay. Yeah, I kind of like this graph a little more. And honestly, when you're looking at numbers like this, it doesn't make so much sense to say percentage. Like, is the percentage of women who got the Nobel Prize in chemistry here lower than it was in this year? Well, technically, yes, lower percentage, but in both cases, it was only 1, and this graph makes that clear. So I'm actually going to stick with this one, this variation, not the percentages. So I'm going to say is X is decade. I'm cleaning this up for a bit more presentation. One thing is I always like to do theme set, theme light. Y is number of Nobel Prize winners. And fill is gender. Title is how has the Nobel Prize gender distribution over time. I'm not coming up with a good title here. It could have been a question. All right, so that's one visualization. Here, notice we're still just doing counting, a little bit of visualization, some polishing, but not doing anything more than that. But we still learned something. I was sort of surprised about this data. Nobel Prize. All right, so that was certainly interesting. That was about the first third or so of our first quarter, maybe first third of our time. Now let's talk. Let's see. Let's talk age for a second. We talked gender. I'm going to throw something else in, which is what was their age when they won. Each has a birth date. At least the I imagine the non-organizations do. So I'll say age, and this is age at the time that they won. So this will be diff time of let's see. I'm actually I'm going to do it a little more simply. I'm going to do it as prize year minus the year. Technically, this is assuming that the prize was given at the end of the year. If their birth was in December, whatever. Year is a function from Lubridate. Year of their birth date. So I've added a column now for age. So the first question I can ask is, what's the distribution of age? Anytime I want distribution of age within categories, a box plot is a great way to go. So I do category, age. And I like to coord flip and category equals FCT reorder of category by age. I love making box plots a little like this so I can get the meaning across. Physics is shifted given towards the youngest, median age. I'm actually curious about this. I thought that FCT reordered by median. It does. Why is the median not in order here? Can anyone catch, did I make a mistake here? If I grouped by category and summarized median age. Oh, of course, NARM. Forgot what the organizations have, don't have ages. So that was one way that you can debug, is you can try an aggregation instead of sticking with the same reordering. All right, so the physics are youngest, literature, economics, oldest. That's interesting. I wonder, has it been changing over time? And to wonder that, I would do a group by, just like I did before, I'm going to do a group by decade and category. Summarize average age equals mean age. While I'm at it, I can grab median age. I'm going to filter not is in a age. And I make it a line graph. Decade goes on the x-axis. Age on the y, color equals category. I don't want that coord flip. So it's me just rethinking how I might visualize. Still not a terribly complicated aggregation. I think I might, let's see, age. Here it is. All right, so actually, I think the most interesting one here is that there's a clear trend in physics wow, that's kind of remarkable. That in physics, winners have been getting older. Economics, they've been consistently among the oldest. Literature, so that's actually, and we actually see one of the reasons is, so economics may seem about, actually I take it back. Economics and literature were similar distribution. Okay, yeah. Economics have consistently been given to people, on average, in their late 60s. Literature, a bit different, but yeah, physics has been getting, the distribution has been getting older and older. You know, I think Einstein won, well, he won for work in 1905. Did he win in 1905? Let's actually find out. I love zooming in on data that we know, like a little trivia about. It's one of my favorite parts of working with a data set is finding out more about some data that you were curious about. So Einstein won in 1921. Was it? It was the photoelectric effect, I think. Let's see. Motivation. Instead of select, if you want to see the whole thing, do a pull. Discovery of the law of the photoelectric effect. That's cool. All right. So the where am I? Here we are. Yeah. So he won in 1921. How old was well, how old was Einstein at the time? Well, I can grab his birth date instead of his motivation. Einstein was 32. So it's not to say that it pulled the number downward, but it's like maybe that was sort of 32 is not right. 42. Yes. Yeah, so Einstein was 42 when he won the Nobel Prize. He was 26, I think, when he in 1905 when he discovered some of his most remarkable discoveries like the photoelectric effect and special relativity. But it looks like he was kind of typical in that people were winning in their 40s during the 20s. Today, the average winner is in their late 60s. So that's an interesting visualization. Peace dropped a lot this year, this decade. That's interesting. I wonder who won Nobel Prize, the Nobel Prize in Peace this decade. Obama was, I think, 2009. But maybe he was 2010. I don't quite remember. Select full name, age, prize. 10 people won, we saw. And oh, Malala, yes. So I think she's a Pakistani rights activist. Yes, so a 17-year-old. I think, a 17-year-old won, 2 people in their 30s won, yes, so that's great. That's excellent. Okay, so that explains part of the reason that we see a drop here to be among the youngest average. Okay, so this shows some things we've learned about the distribution and change of age. Okay, so anything else we can grab out of here? Well, we can do a few other things like we can do things like count birth country. Whenever you do a count of a factor like country, you really need to FCT lump to say birth country with, let's say, the top 15 countries and then other. So we see the US, other, then the UK, then Germany, and following on from there. So the, and we can, while we're at it, we can throw in we do this and we throw in a category. And then we say, so we see doctors and physicists disproportionately born in the United States. And then from this, we would create a faceted graph. Do we want to create it? Sure, why not? What I do is say, but here I want fewer of 9 and an other, and we'll say birth country, and fill equals category. 2 ways we can do this. We can just graph it like a stacked bar plot. Or we can, don't forget, birth country equals FCT reorder birth country by n. Okay. I thought I saw the US having more than other when we first did our count. Any ideas here? This is interesting. What if I did birth country weight equals n, other is in the front, okay? Oh, that's right. Of course, I changed 15 to 9. I said these are 9 countries plus other. I put a few more countries into the other category. Okay, so we can see, can you see any big things about the difference in distribution? Not too much. I might facet it by category. I love when we have 6 categories. It makes for a nice facet. The reason it looks funky, actually I don't mind it looking funky because I want to be able to compare the distribution. So we can tell here, for example, is that peace is the most evenly spread out one, in the sense that peace is is spread all over the world. I think it makes a lot of sense. We have activists and politicians coming from all over the world. It looks like the other industries tend to be shifted largely towards high-income countries. I wonder if that's been changing over time, and I have some ideas of how we might look at it. But first, yeah. I take it back. Peace and literature are highly international, but especially economics, to a certain extent physics and medicine, shifted towards the U.S. So that's interesting. Actually, let's quantify this a little bit more. In a previous screencast, we learned about the WDI package for getting World Development Indicators. What I just am noticing here is we can look at like how does it differ between the high-income world? How does distribution differ? Like here, if I try and combine, like, U.S., UK, Germany, these are all countries with these are all wealthy countries. They'll have very large academic communities. I want to kind of lump them together into the high-income world and ask, like, how does the distribution differ between these? So I want to bring in a bit more stats about countries. So I think I might go to WDI. I've used this previously, but what I'd say is WDI search for GDP. That's good. I need to remind myself, I used it in a previous screencast. Actually, I take it back. I'm going to go ahead and pull it from the previous screencast, which was student-teacher ratios. And I grabbed GDP of countries, but like this. Not to mention some things like, I got a whole bunch of, this is actually just me grabbing from that previous week. It's all up in GitHub if you'd like to grab it yourself. And I'm just getting GDP per capita and some extra columns. So what I can do then is say, is here I have country, and I can actually say, take my Nobel winners, interjoin them with my indicators by, and it's called country. Birth country equals country. And I've just added GDP. I'm going to select country, GDP equals this. I don't want to keep dealing with GDP per capita. I'm grabbing each country's GDP per capita in 2015. 2015, I think I can get more. It's not going to make a big difference. But I'll grow one more. I don't remember what years it has, but here we go. GDP per capita. I combine with GDP per capita. I'm missing a whole bunch. If I anti-joined, what countries am I missing? For example, maybe the United States. United States has a different name. So I think, Russia, I think is maybe Russian Federation. So if I take indicators, if I take my indicators, I can do, there's actually a few ways to do this. Okay, here's the way I'm going to go about this. Country code. The same person who created the WDI package. I'm embarrassed, but I can't remember his name. But he did a really. Vincent Errol Bundock. The same person who created the country code package. So I'm going to show for a moment how I'm going to turn these into these names, like United States. In the Nobel winners, they're United States of America. But I could match them up differently. They could have been a bunch of other strings. So what I'm going to do is say mutate country code equals, and there's a function called country code in the country code package, and say I want to take the country. It is currently, I only know this because I've used this function before. It is currently country.name. I want to turn it into ISO2C. ISO 2C? Yeah, I think so. Birth country. This was an adventure. Some strings were matched more than once, like British. There's British India parentheses Bangladesh in here. Wow. Count. But it should get my United States. It does it the best it can to turn these into actual names, into actual country codes. And at that point, I can use my WDI actually has standard country codes in here. The column is called ISO 2C. Oh, yeah. Well, that's going to happen. What I do is add country code, and now if I say which can't I match by country code, pardon me. I see I still can't match Scotland, and these are a lot of countries that either they're not quite a country, they're like in the UK, or maybe this was when it was a separate country. These are like, yeah, these are noting things like this was in Russia, this is Poland, but when it was in Russia, and so on. So birth country can be a little confusing because not all countries exist anymore, and so on. I think it's fine to basically not count those people. Okay, I just wanted to take a quick look at that, and here we are. But the critical thing is we've now added how rich each country is. I can even add not region. There's one called income. Yes. Nobel winners countries. I've added some fields to it. The warnings are, like I said, because of ambiguity. And now I can say count income. And I actually have, oops, I inner-joined. I meant to anti-join. I meant to inner-join. Now I have high income, upper middle income, lower middle income, low income. And the reason I was doing this is I was curious about a few things. One, I was curious what I saw the country analysis, and I'm like, that's too many. It's too many like bars. It's like too much information. I want to synthesize it, and I'd say I want to synthesize it into income level of the modern country, even though this is over a long period of history, and ask where are they coming from. So I can say count, category, but also income. And I facet by category. And let me coord flip. Is the income sensibly ordered? It is not. Yeah. So one thing is I want low at the bottom, then lower, then upper, then high. So what I can do is say in one direction or another. Right now, income has the levels high, low, lower middle, upper middle. If I move low and then lower middle income to the front, nope, it's actually, then it'll still be in a funny order. All right, what I do is I say, here we go, mutate income equals FCT relevel income to put, relevel takes a vector of what I want to put on the bottom. Low income, lower middle income, upper middle income, high income. So this shows distributions a bit differently. And one thing this shows is, I'm going to do it as percentages instead of totals. Notice I often do this group by and then percent equals n over sum n. Here we go. So, nope, that should not, these should add up. Oh, I'm sorry. There we go. Okay. Yeah, this actually gets the idea across. Notice that, and I'm going to document it because this is a little bit puzzling, as I can say, current income level of birth country. percentage of this category's prizes. What this shows is that peace and literature at least have some distribution across various parts of the world: high income, middle income, middle income, low income. Especially, yes, the peace is basically the only place, and one from literature, you see people from low income countries. That would be a lot of sub-Saharan Africa, and some parts of Southeast Asia. So, and then we're seeing like, yeah, so peace, literature to some extent, much less so medicine, chemistry, physics. All right, so that's one thing we learned about, like, where do people come from? Where do Nobel Prize winners come from? All right, so that was a bunch of analysis just of this table, bringing a little bit of country level data. And I could have done it by region as well, North America, South America, but I don't like doing it by region because you'll say, oh yes, mostly from North America and Europe. Like, okay, but mostly I want to combine like US and much of Western Europe, but then I want to separate Mexico as another income category. So I do like World Bank's definition of high income, upper and middle income, etc. It's one I've used before in analyses. Okay. So let's talk publications. What was that other one? Nobel winner, all pubs. Here we go. Well, this is frustrating. Why does laureate name, why am I seeing it? I'm not able to join this with the other table. That's okay, it looks like, because it looks like it has the category data. All right, so it looks like with just chemistry, medicine, physics. All right, so that's as much we've seen as much as we're going to in Nobel Prize, etc. But now we're going to be looking at some publications. First question I have is this already filtered for pub year is before they won the prize? So pub year, prize year. No, it isn't. And once I do that filter, I notice that that it went from 90,000 to 57,000. So that means of the papers we have in this data set, more than half were written before someone won the Nobel Prize, but plenty were written after. So why did I do that analysis? Because I might want to say group by the laureate name and the laureate ID. Is laureate ID in our Nobel winners data? If so, then I would be able to do a join. Good, it is, so I could do a join if I wanted to. All right, that's just useful to know. I'm going to aggregate across winners. What do I aggregate? I'm going to summarize papers before prize is the number of rows number of rows there. So this is showing like that this person. Oh, I need to probably grab a few more things. Category, prize, year. This is showing that this winner of the 2016 Nobel Prize in Physics had 143 papers as of then, which, for one thing, wow, but this said 614 papers. That feels a little bit odd. Maybe, Nobel winner, all pubs, filter, full, no, it's just laureate. I'm curious, is there duplicated data? Do that account titles? Maybe a little bit. Like, yeah, like I could quickly say, this lowercase it's distracting. It's not going to affect our analysis, but here we go. Different publication years, different journals. I didn't know you could do that. All right. Same title, different journal. Okay, let's see. But it's still fairly rare. So if I counted title, do I see any like egregious, the same paper got appeared many times? Not necessarily, and you could, if I counted title and the author name, it probably would go down even more. Yeah, I'm just not going to worry as much about that. Okay. So this person had 600 papers. Some people do. That's pretty cool. I have like 6 or 7, but then I'm not really up for any Nobel Prizes. So if, let's see. So prize, let me see. This is the prize year. There's a number of papers before the prize. What else might we be interested in? I actually would be interested in the average, let's see. Title. I was thinking the average, like, I'm thinking of how to make this expressive. How many papers in, say, the previous 5 years? Papers. Let's try this. Papers in last 10 years. Papers, let's call it before prize 10 years. If I was going to make more of these, I'd find a different approach. But I'm going to say some where the pub year is greater than or equal to the prize year minus 10. It's going to be lower. This is a good example. This first one's a good example. This person won for physics, had 143 papers, but it looks like had mostly retired. Not necessarily, but like I had 2 papers in the previous 10 years. Could also be a data quality issue for sure. This winner as well, but if I take a look at this person, what if I did physics? All right, so this is a winner. He was, I think, what is that? He would have been 82 when he won the prize. So certainly not surprising if he'd retired first. And yes, that's like, yeah, aside someone had retired. Another way of viewing it, other than papers in the last 10 years, which is kind of an has retired metric. Honestly, let's do last 5 years. I think that'll be a pretty clean, like, yeah, like I think if someone goes 5 years while publishing 0 to 1 or 2 papers, it's probably a really good bet that they've retired, especially someone as prolific as some of these authors. So this will be like a kind of an is retired metric. All right, and yes. So then I could also say average paper age, mean prize year minus pub year. So, for example, this person, David Thalos, the average paper that he'd written was 33 years ago. So probably had several decades of activity, but then in the middle was 33, whereas some people are early in their career. So this is kind of a representation of someone's, I'm actually going to do median paper age, maybe. Yeah, probably pretty similar, but this gives the impression like someone whose median paper age is 8 and are still active, probably something like 16 years into their career. Someone who's this person published 13, but the median one was 54 years ago. They're certainly retired. You can see the papers before was 1. Nobel Prizes are not given posthumously, so generally they're never given to someone who's already died. So the we know that we can say that here, if someone hasn't published, they're retired. So I can ask a question like, fraction had retired based on their papers in last 5 years. So across chemistry, so what I can take a look then is say, take a look at our winners across all publications, group by category, and the decade. Here I need to recreate it. I don't have my same logic. I'm going to go grab this. Category and decade. Oh, here I need winners summarized. Here I've created a new data set where I said here for every winner, here's some stats about them, like their median paper age. I got one more, which is winning paper age. I don't know whether multiple people ever win, but just in case, whether there be multiple papers, but notice there was this great column, is prize winning paper. That's really handy, where I can say mean of prize year minus pub year, only indexed. I'm doing a mean just in case someone has somehow multiple papers. is prize winning paper equals yes. Here we are. This person actually published the prize-winning paper early in their career. Ooh, that tells me another question I want to ask, which is where is the work that someone wins their Nobel Prize for within their career? That'll be cool. I'm not going to look at that. Yeah, I'm going to look at that next. But this person, it looks like it was probably in the first half of their career. In fact, often it seems like it's older. Yes. Okay. So I'm going to start with summarize, where we say, this median is bugging me. I'm going to make it average paper age. It's probably pretty similar. I don't want to take an average of median. It's going to be confusing. What I'm going to say is average paper age, mean of average paper age. I'm calling it winners summarized. Here we go. So we can say, oh, and average papers, mean of papers before prize. So we can say, yeah, I think our data is lower quality, long way back, our publication data. So yeah, so we might end up doing some filtering or such, but yeah, I'm sure average papers has been going up. But what's the average age of a paper? Like, and then paper age is a measure of how far along you are in a career. Average winning paper age is the mean of. That's measuring the gap between when someone does Nobel Prize winning work and when it's recognized by the Nobel Prize Committee. So winning paper age. Bingo. So, so we looked already at like people age, but now we can say how old is the work that won, and how does that differ? So I can say, and actually that's my favorite thing to look at, so I'm going to start with that. I had neglected to do color. Wow. Huh. Okay, so one thing is we have some missing data, but another is the time between when a paper is published. Labs y equals time paper was published and won prize. Right, need a couple of visualizations of this. Okay, that's a really, like, you don't often see curves that like kind of smooth. It looks like the average time between when a paper gets published and wins the prize has been steadily increasing. So I mentioned before, Einstein won, that was 16 years past when he published the photoelectric effect in 1905. Some trivia I didn't know. But it looks like but that was above average then, it would be below average today. Today you have to wait 25 years between when Nobel Prize winning work happens and when it's recognized with a Nobel Prize. That's super interesting. Well, it also tells me that I want to make an aggregation of not just like a summarized by winner. I kind of want to look at those winning papers, but first I want to get a bit more data about them. For example, like I said, how many winners, how many prizes someone won first. So. I wonder if Marie Curie's papers are duplicated here. Hope not. I'm trying to take this data set at face value. So what I'm going to do is say this. Group by laureate ID. Mutate rank. And let's throw in a category just in case they win in multiple. And prize year. Just in case. Okay. What I'm going to say is papers before is actually, this is how many, this is which index is this paper in this person's history. So rank is a super helpful window function. I'm doing a grouped mutate. What am I doing here? If I said laureate name and -1, because if something is, you'll see what I mean in a second. Papers and pub year. Let's yeah. So and papers before, arranged by laureate ID, by pub year. Okay. I am doing something wrong. Okay. Oh. Here it is. Rank needs to be actually dense rank, which handles ties a bit differently. Nope, not dense rank. I need... what I want is, this person had never published papers before. If I did this without the -1, they both get a 1.5, a tie. I don't want that. I want the ties method to be first. Yes. Here it is. Min is what I wanted. Oops. Yeah, I wanted this. Here they published first. This person had published, this is first paper, second paper, third paper, fourth paper, fifth paper, sixth paper. All right, and this is the, this is assuming that the order is meaningful so far. But yeah, this is saying like how many papers did someone publish before. So this is a grouped mutate. I can add more things to my grouped mutates. For example, I could add, let me see, I could add total papers is N. That's how many papers someone had in their entire career. And I could also add position in career. I could use a rank function for this, but I could also just do this divided by total career, total papers. I'm going to call it paper index, so it's like, there's a few ways you can do your off by 1 here. It doesn't really matter. What this is saying is, this is very early. I'm going to throw back that -1, papers before. So this is like the first paper in this person's career. Then we watch it go through. Yeah, pretty good. I'm going to drop my select so I leave in the rest of the columns. Here we are. So we can say, like, for this person, the prize-winning paper was the first in their career. Well, that is, let's double-check that one. And the Nobel Prize for... Well, if it's very common, I'm going to be puzzled about that. Not puzzled, but good for him. He was born in 1928. He would have been about 29 at this point. All right, interesting. Okay, so, all right. So why did I do this? I wanted to add a couple of columns to this paper data set. So I'm going to call this actually papers enriched, pubs enriched. I'm going to say filter is prize-winning paper. And now I'm going to look only at the prize-winning papers. So these are 875 papers that have won a Nobel Prize. Do we have the same paper multiple times for the same author? I think we discovered we did. Oh, I neglected to ungroup. We don't. No, that happened. Okay, but yeah. So what this shows is, So what this shows is, this person this year, won in 2016 for this publication year. So the question is, where in someone's career was a paper published? So I can answer this question with distribution of position in career. Whenever I want a distribution, what am I graphing? That's right, a histogram. This is really, I would not quite have suspected that. That's really interesting. Generally, most people get their Nobel Prize for work they do early in their career. Actually, I take that back. One of the reasons that it doesn't surprise this might happen is that people that do some Nobel Prize winning work, in fact, even if it doesn't win for decades more, as we saw, they're likely they end up that gives them the kind of tenure position respect within the field to do a lot more work, to get a lot more papers, to be in a lot of collaborations, and that could lead to hundreds of papers. So plenty of people can do just a handful of papers and then very early on do their the best work, some really good work. There's other reasons to expect this now that I think of it, including that several decade lag. So let's take a look at how this has changed over time. So what I'm going to do is say, do I have a decade column? I do not. I'm going to add it so that I can keep analyzing it effectively without having to keep, I'm adding it to the raw data. And group by decade and category. So for each decade of a prize, that's a prize year, not of a not like when the paper was published. So I can except that's not what I want here. I want pub decade. Probably. Yeah, let's start with pub. Let me see. Yeah. No, I'm going to start with a prize decade, but I should make that unbelievably clear. Rerun my first one. Now I have it. Group by prize decade and category. And now I can summarize for what's the average position in career. Notice how much aggregation I like to do in these kind of analyses. I neglect to do category. All right, so where was a paper published in someone's career? Has that changed over time with the prizes? I think we have some bad data back here, but mostly it looks like it's been pretty stable. There are these random jumps are the kind of thing that make me think, yeah, we're not seeing like a trend. That's pretty important. Time stationarity, if we're going to look at it in a question like this. So I'm going to, yeah, this is suggesting that in general, the average paper was the average Nobel Prize winning work is done early in someone's career. We're seeing that hasn't changed, really changed over time. Don't know, like chemistry here, maybe one person won for, a couple people won for some really late in their career work. Interesting stuff. So people win, older people win, but usually there's decades between when. Now, how does that? Let me see. This is average position in career. But how about the average age of the paper? So I can say, let's see. Did I look at that somewhere? Average paper age. No, I looked at it here, but not. Oh, no, I did look at that. What am I talking about? Oh, yes, of course I did. Yes, that was exactly what I looked at. I was trying to remember. Winners summarized. Where's my decade? Oh. Prize decade is the column that I added. Took a little bit of adjustment. Yes, that's right. What I found is that, so how do I explain, actually, I'm trying to understand this. All right. Oh, I'm starting to get a feel for it. No, the average Nobel Prize winner today in chemistry, medicine, physics wins for work. Actually, this is something I would, this is the way kind of I would summarize this. I'd say the average Nobel Prize winner in chemistry, medicine, and physics is winning for work that's about 25 years old. Work published about 25 years ago, about a quarter of the way through their career. So where I see that is actually about a fifth of the way through their career. This is not, I don't like how kind of messy this is. I think it can be kind of biased, kind of shifted by a lot of things. So what I might do, notice that, and I also have age somewhere. Here we go, here we are, in their late 60s, and is winning, here we go. So this is the way we could, the average recent Nobel Prize winner in chemistry, medicine, or physics is in their late 60s, so I said recent because I'm looking at the trend over here. And you can kind of see your chemistry, medicine, physics, that explains, that makes you feel a bit better. What I can say is category in chemistry, medicine, physics. There it is. So what we can say is when someone gets when someone does the Nobel Prize work within their career, has not generally been changing. It's usually about a fifth of the way through their career. However, people are waiting longer for it. So here it is. They're about a fifth of the way through their career. I'm going to tidy this a little bit. Average position in career is actually a little weird because we could certainly do it, but it's like it doesn't mean the same thing as age. So maybe let's try average age. So what I can do for that, there's a few more minutes. What I can do for that is I'm going to move this to an appendix. Here's our age, and I can say, what I can say is take our Nobel winners, distinct their laureate ID and their birth date, and interjoin it with our pubs enriched by laureate ID. These are not working. Maybe the laureate IDs don't work across the tables. If that's disappointing. All right, skip that. I can't say someone's age when they won. I'm guessing, given that the average winner wins for work that's given that the average winner is in their late 60s and is doing it for work 25 years ago. It's probably in their they're probably about 50. They're probably about they probably did the work when they were about 40. But yeah, someone's frequency of papers generally goes. My impression, just from what I remember from academia, frequency of papers per year goes up later in one's life as you later in one's career, I should say, as you do more and more collaborations with people. So the here we go. I'm gonna, and I can just confirm that for a moment by take a look at our pubs enriched. I grouped by this and I actually said I could add a few more columns. First pub year is min of pub year. Why did I do that? Because that lets me give a bit more of this feeling for someone's distribution of papers across their career. What I can say is, what's the distribution of pub year minus first pub year? First of all, some people publish into their hundreds, which is what? That is not the best data. But what I'm going to do is say first pub year is less than, I don't know, 75. Just, not that's an absolute limit, but, oops. I don't like my funky patterns with my bin, that my bin width is leading to. Here we go. And that was, by the way, was because these are only integers. All right, this is showing the arc. I can say facet wrap by category. And, Ooh, I've got a great idea. Yes. Here's this gets it across. Fill equals is prize winning paper. Yes. I'm trying to remember how can I make this a density instead of a. I don't like that there's more paper. That's fine. Okay, yeah. So what this is typical arc of a Nobel Prize winner's career. This actually has an issue of right censoring, where people that have won the Nobel Prize very recently might still be in the midst of their career. But yeah, I didn't. Subtitle is, given that it's been 25 years or something, it might not be. It probably isn't having too sharp an effect, but I could filter it. I could say, yeah, here's what I'm going to say. I'm going to say prize year for winners between, I'm actually going to do 1910 because we saw the early data was a little messy. (1910) and 2000. That way, most of those people will have already retired, and we can see the distribution of their years. And here we can say X is I don't have their age. Like I said, I don't have people's birth year, but I can. I wasn't able to join between these two because the names are in different formats. Years between first paper and this paper. Years into their publishing career. So this shows, yes. Well, this shows, I actually have another variation I could do on this. I could do this as a density plot. Yeah, you pick your preference, alpha equals 0.5. Pick your preference, but this shows, yeah, actually I kind of like this. Physics, medicine, chemistry, it tends to be, the winning paper tends to be in the first, it's almost always the first 20 years of their career. And that's why you can see that someone's productivity spikes peaks about 30 years after their first paper. So we can see papers are in the first, most Nobel Prize winning papers are in the first 20 years of someone's career. And we have the conclusion that someone's overall productivity, publishing productivity, remember that this is not all scientists, all tenured scientists, this is specifically people that won the Nobel Prize, so at the top of their fields, probably peaks about 30 years after they publish their first paper. I was 21 when I published my first paper. I was 23rd author out of 37 authors, and my publishing career productivity peaked about 5 years later, and I publish much more rarely now, mostly things left over, but I am certainly not. So that might tell you I'm not going to win a Nobel Prize, which I probably could have told you already. But yeah, so to review, what we learned is by analyzing this really great data set of Nobel Prizes, we were able to see. We found out, we just took a look at like how many winners there are per year, so we had a better understanding of this. We looked at some trivia questions that might help next week at bar trivia, like that Marie Curie and Linus Pauling are the only two individuals to win Nobel Prizes in two different fields. Yes. So and then we saw that Nobel Prizes are almost exclusively given to men historically, except in peace and except to a certain extent peace and literature, and somewhat recently in medicine. All right, and we learned that that generally the age of Nobel Prize winners tends to be oldest, especially for literature, economics, younger for physics, but we see that it has been changing over time. And in particular, when we get to, we see some things about the distribution of rich countries versus lower income countries in terms of producing Nobel Prize winners. And so only peace and literature were rather internationally spread out to any extent at all. And finally, we saw a whole bunch of things about, most notably, this is actually, I think this is my favorite result. The time people are, I'm going to entitle this, Scientists Have to Wait Longer for a Nobel Prize Than Ever. I really like this, that conclusion. I wonder, yeah. It doesn't shock me. I could imagine a lot of real reasons the field is like that. Like the field's getting crowded, people takes time for work to be appreciated, and they're still working through maybe build up a backlog of people who deserve Nobel Prizes. But I think it's really it's definitely an interesting conclusion. Okay, well, I thank you so much for joining me. I had a lot of fun. I hope you did, and I'll see you next week.